should go get them.
Oh, yay. But especially the bubbles. I think we're going to blow bubbles.
So today we're going to be making bubbles. We're going to need to make sure we have our bag of supplies with us, as well as our worksheets, a pair of scissors, a lot of water, something we can write with, like a pencil or a pen, a bowl we can work over, and some paper towels, and a regular towel that we're going to keep our workstation nice and clean by using. We want to make sure that we do not spill any water or soap on our computer. That would be a big uh-oh. We'll ruin our computer if we spill water on it.
I have a question.
Yes?
What's this red thing?
Don't worry, we'll get there. I'll describe what everything is when we start using it, okay? Yes, Dean?
So first I took this thing out, yeah, then I unscrewed it, and I realized the red thing was bubble poppers.
Ooh, so you know what it is, that it's bubbles. Yeah, all of today, we're going to be working with bubbles, understanding the science behind why bubbles form and how they form. To start today, I'm going to share a PowerPoint slide. Can everybody see the picture here? Yeah? Who wants to raise their hand and tell me what that is? Yes, Audrey, what is that?
It's a bubble that's on a little...
Go ahead, Speedy. Okay, tell her that.
I don't remember what it's on, but it's a bubble that has soap on the thing.
Yes, it's called a bubble blower. That's how we're going to form our bubbles. How we're going to get our air inside of them. I heard Audrey tell me something about soap. Who knows what she's talking about when she says soap? How do we use soap to make bubbles? Yes, Cadence.
They hope the bubbles get super sticky to form.
Yeah. So soap is sticky. It changes how much our water wants to stick together. It helps bubbles form. Audrey, you're raising your hand. Want to unmute yourself?
Yeah. It forms from you blowing too.
Yeah, we blow out air. We are forcing air into the soap. The soap creates a layer around the air that we blew out. That's what the bubble is. It's a layer of soap around air. Who here has ever blown bubbles before? Yeah? What shape are bubbles normally? Julia, do you want to tell us?
Bubbles are usually a circle.
Yeah, they're spheres. They're a big 3D circle. Has anybody ever seen a bubble that's not a circle? No? That's going to be one of our goals for today, is to see if we can observe a bubble that's not a circle. What color are bubbles? Yes, Julia, What color are bubbles?
Kind of like clear.
So they're opaque and clear. We can see through them. Cadence, you want to share?
They're clear and rainbow when they're put in the sun.
Yeah, they have sort of a rainbow color to them. That's because the light that we see through them is diffracted. It means it's spread out into all the colors. Normally, we're able to see all colors of light around us. But when we put light through something that diffracts it, then we see the colors spread out so we can see them all separately. What about a rainbow? What color is a rainbow? Audrey, what color is a rainbow?
All sorts of colors, except black and gray.
Yeah, it has all sorts of colors, Audrey just told me. Cadence, you want to share?
A rainbow is red, orange, yellow, green, and blue, purple, and pink.
Yeah. So that's Roy G. Biv. That's all the colors of the rainbow in order. Thank you, Cadence. It's because the light from the sun is spread out because of the water in the air, like the raindrops. That's why we see rainbows. When we play with our bubbles today, we need to observe the color of them to see if we can see rainbows, okay? Okay. Today, one of our goals is going to be to make the best bubble solution. A solution is a liquid that has multiple things in it. So this may be soap, water, glycerin, sugar. It's when we mix a whole bunch of things into one liquid. Let's go around and talk about what we think would make it a bubble so it's the best bubble. Who wants to start? Audrey, what would make something the best bubble to you?
Some soap and water mixed together.
So you're telling me ingredients for how to make the bubble solution. We can try that. Dean.
How I mix the best bubble, so then I would mix some sugar and some soap together, so then to blow it out, there'll be a gigantic bubble in a gigantic bubble blower.
Ooh. So Dean told us how he would mix his solution as well as what the best bubble would look like. He told us that the best bubble would be big. Who agrees that a really good bubble would be very big? Yeah, we all think a really good bubble would be big. What else would we want in the best bubble besides it being big? Audrey.
We could put the purple thing in, and then we could mix it in with the other two things that we all wanted in.
Ooh, so you're telling me how to make your bubble solution. If we were to look at a bubble though, how do we know if it's a good bubble and we like it versus it's not a good bubble? So we said it would be big. What else? Cadence. What do you think a good bubble would look like?
It'd be strong and hard to pop.
Yeah, we don't want our bubbles to pop easily. We want them to last a long time.
And like float
It's a great
over into outer
characteristic.
space.
Well, maybe our bubble could go to outer space. I think it would have a hard time due to a lack of air. Who here wants to be able to hold or touch their bubbles? Yeah. Okay. So we're going to begin our adventure to find the best bubble solution. We are going to make 2 different types of bubble solution, means the liquid, and then we're going to test it to see whether the bubbles are good or bad. To start, we're going to need our cups. We are going to need our towel and bowl. We are going to need our pipette. And we are going to need our bag of liquids. We have glycerin and dish soap. Okay. To start, we are going to take our liquids out of our bag. We are going to make sure our workspace is set up. That way we do not make a mess on our table. So what I'm doing is I'm putting my towel on the table. I'm putting my bowl on top of it. And I'm going to work over my bowl. I'm now going to take apart my cups and lay them out. I want to be able to pour liquid into both of my cups. My first cup is going to have my dish soap in it. So I'm going to pour out my dish soap into one of my cups. I want my glycerin, that's the clear liquid, in the other cup. I now have 1 cup with dish soap and 1 cup with glycerin.
Do we pour all of it?
Yep, we can pour it all in our cup. In chemistry labs, it is a good thing to do is to never smell our liquids like this. We are going to use a wafting technique. Means we're going to do this to smell our liquids if we want to smell them. This is called wafting. We're pushing some of the air near our nose so we can smell it. Who wants to tell me their observations about what our liquids smell like? Dean, what do you observe?
So when I do it with the soap on this, so it smells like very fresh flowers. And this smells like dead flowers.
Oh, so we don't like the smell of our glycerin, Dean's telling me. Audrey, what are your observations?
One that looks like blue, it kind of smells good. And the other one, it really doesn't smell that bad, but it kind of doesn't have a smell too.
Yeah, so our dish soap, that's our blue liquid, smells strongly. A lot of our nose sensors, our receptors in our nose, can pick up the smell of our dish soap. We can't smell our glycerin very well. Cadence, what are your observations?
The dish soap smells like something good, like laundry detergent smells good.
Yep, it has a scent.
And the glycerin doesn't smell like anything.
Yes, so our vegetable glycerin, I'm hearing, doesn't really have very strong of a smell. Okay. We are now going to make our bubble blower. We're going to pick up our pipette. We are going to pick up our scissors. And we're going to cut half of the bulb of our pipette off. So we're cutting our bulb in half. Great job. This is going to serve as our bubble blower. How we're going to use it is we're going to dip it into our liquid, our solution. We're going to pull it out. We're going to squeeze. We're going to see if we can make a bubble. Do you see a bubble forming in your pipette? Cadence does. Audrey, you want to share?
I saw like 3 bubbles together into one big bubble.
Ooh, so our bubbles stick together, Audrey's telling me. Excellent observation. We are going to use our worksheet to make notes about our bubble solution. So we have our cup of dish soap. We're going to try to make 2 bubbles. That's our trial 1 and 2. We are going to rank our bubbles based on their size. There's no bubble, they're small, medium, or large. And then how good our bubble is. We're going to say this quality is whether they stay as a bubble or pop. So let's make our first bubble. That will be our trial number 1. Can we make a bubble? Oh, I see Cadence has. Excellent. We're then going to record our data about our bubble. So if you can make a bubble, you're going to record how big it is, whether it's small, medium, or really large and big. Yes, Dean.
So how I blew my bubble shows that there were half a bell. So there was just like kept singing. So like the top of the pipette, then it formed 10 bubbles at the same time.
Ooh, Dean also saw that he can make a bunch of bubbles at once. Thank you for your observation, Dean. Audrey.
I observed that when you actually squeeze like closer to the part that's not as big and squishy, it actually makes more bubbles in yours, and big and medium.
Ooh, so you're learning how to use your tool, your pipette blower. You're seeing that if you force more air in by squeezing up higher, you can make more bubbles. Thank you, Audrey, for sharing that with us. Oh, Julia, I see, has figured out another way to use the bubble blower.
So when you like dip the pipette in and then you blow it on the other end, it makes a huge bubble.
Yeah. Yeah, Julia is showing us another way to make a bubble, and so is Dean. So we want to make 2 bubbles by using our dish soap before we move on. So if you have not made 2 bubbles and recorded your data, you need to do so at this time.
When I tried it, it actually floated.
Mhm.
And then it popped, I guess.
Okay. We're going to move on to our next bubble solution now. So we have a cup of glycerin. We are going to find out whether this is a better or worse bubble solution. So we're dipping our bubble blower in. We're going to use the same method to blow our bubbles. So we can squeeze or we can blow. We want to make sure we blow out. We do not suck in. Cadence, you want to share your observations?
It made tiny bubbles.
Oh, it makes tiny bubbles. So we can record our size of our bubbles for our vegetable glycerin. We also want to record how long our bubbles last. Do they last longer or a shorter amount of time than our dish soap bubbles did? Audrey, you want to share?
When I did it, I actually blowed in and it made a very big bubble.
We do not want to suck in. We don't want soap in our mouth.
Like
That's
I
good.
went out.
Oh, yes. We can blow out. We can go just like we blow out candles.
Yeah, and then it made a giant bubble.
Great job, Audrey. So we see that our 2 bubble solutions so far make different types of bubbles. Cadence told me that the vegetable glycerin makes a lot of small bubbles. They also last a long time. Our dish soap produced really large bubbles. We are going to make another bubble solution now. What we are going to do is we're going to pick up our dish soap cup. We are going to pour a small amount of water into our dish soap cup. We don't want very much, just a small amount of water. We are going to use our bubble blower to stir it up really well. We are going to see what happens to our bubbles. Do we like our bubbles more now that we have water in there? Do they get larger or smaller than before? Cadence, you want to share?
A tiny bit larger.
Ooh, so they get larger. We said that a good bubble was large, so we made a better bubble solution. Dean, what is your observation?
So my observation, so you can look at this.
Ooh,
And it also lasts longer. And wait, so what if a bubble got this big? Then that would be impossible.
it's not impossible. You can make really large bubbles. Yeah. Audrey, did you want to share an observation?
When I mixed it up so much very fast, it actually, when I blowed it, it made really big.
Ooh. And Cadence, you want to share an observation?
If you use the top, you can make the same big bubble with pushing less.
Yeah,
And it stays even longer.
yeah. So when we push up,
Oh, and it
Cadence
sticks
is
to
telling
my
me the
finger.
bubble lasts longer. It's because we are not pushing
It's
as
staying
much.
on my finger.
Yeah, it is, isn't it, Cadence? So does a really, really large bubble last longer or shorter than a small bubble? Let's try. So we're going to try to make a really large bubble. And we're going to try to make a small bubble. We're going to see which one lasts longer. Cadence is showing me that her small bubbles last a long time. It's because the surface of our bubble is very weak. If we are to poke at it, or if we try to shove a lot of air inside when it's really large, it will break. We're going to test our new bubble solution compared to our vegetable glycerin. Which one do we like our bubbles in more? Julia is showing me the new bubble solution of dish soap and water. Dean wants to share? Yeah?
So how you make bigger bubbles, spin it, so you dab it like this and then turn it, and next, wait.
Oh, yeah. So if we get a lot of dish soap, so it covers the entire part of our bubble blower, then we're able to make bubbles. Great job for that observation, Dean. Thank you. We are now going to pour very, very small amount of our vegetable glycerin into our new bubble solution. We don't want very much. So Cadence told me that our vegetable glycerin allowed us to make lots of bubbles. We want a bubble solution that'll make a lot of bubbles, they'll last a long time, and they'll be very, very large. Huh. Yeah, Audrey showed me her new bubbles. And Dean's showing me new bubbles. Julia just showed me a bubble that floated away from her. So we saw that the properties of our different liquids would help us blow better bubbles. We made a solution. It means we mixed multiple items together to make our new bubble solution. Okay. We now want to pull out the tiny bottle that's in our bag of supplies. This is another bubble solution that someone else made for us. We are going to see and how well this bubble solution works. So we're going to open it up. We're going to be very careful not to spill it. We're going to try to blow some bubbles out of our bubble wand. wants to tell me what they observe? Yes, Julia, what do you observe?
So like when I blow it, it goes away for like 1 second and then it pops.
Ooh. So they don't last very long.
Whoa.
How many?
Never mind.
Oh, we're seeing that how hard we blow into our bubble wand makes a difference when if bubbles pop.
And then it went like 10 seconds. Wow.
Ooh, nice, Julia. Audrey, were you raising your hand before and want to share? You want to mute yourself?
When you blow like harder, then it pops sooner. But when you blow less hard, it pops later.
Excellent. Thank you for sharing that with us, Audrey. So we're seeing that our bubbles are weak. And if we put a lot of force of air on them, they pop. What can we observe about the number of bubbles? Do we see more bubbles or less bubbles with our bubble solution? So do we see more bubbles with this bubble solution than what we made? Or are there less bubbles? Yes, Dean.
So what I observed, so that when you blow this, you will have to blow it. So your air will have to be very tiny. So then you can sometimes see it from this gigantic of a bubble.
Ooh. So yes, if we were to blow gently, our bubbles can get larger. Cadence.
I blew a bubble more than a minute ago, and it's still staying.
Ooh. So this bubble
On this thing.
solution allows our bubbles to last longer, Cadence tells us. We're going to spend 1 more minute playing with our bubbles before we move on to another activity. Dean, you want to share an observation?
So this bubble was about to pop, then it just popped. But when it was about to hit the table, I swung it, then it hooked on to the bubble maker.
Ooh, so our bubbles stick to things like our bubble blower? Yeah. Great job, Dean, for that observation. Ooh, and Audrey's showing us another bubble. Yeah, lasts a long time, doesn't it? Okay. Julia, you want to share our last thought before we move on?
I'm not sure when this was blown, but there's still a teeny tiny one on my hand.
Oh, you still have a bubble. Nice. Okay, we're going to move on to our next experiment now. We are going to need our plastic plate. We're going to need our old bubble solution. We're going to dump our bubble solution onto our plate. Our goal is to make as many bubbles as we can on our plate. Let's see how many bubbles we can make. We're going to spend 1 minute. Then we're going to see who made the most bubbles on that one plate. Yes, Dean.
So what I was observing, so if you shake the bubble very well and then take it up and then put it down, sometimes a bubble can form.
Yeah. You see that you can form bubbles on your plate. Who else has formed bubbles on their plate? Cadence has. Julia has. So let's look on our plate. Do we have a lot of bubbles now on our plate? Yeah. Let's look at them really closely. What shape are our bubbles? Cadence, you want to share?
Whenever my bubbles together trying to form a big bubble, I got some square bubbles in other shapes.
Ooh. Cadence sees that there's bubbles that aren't circles. Let's look closely at our bubbles. Does anyone else see some bubbles that are not spheres, that aren't round? No. Means you need more bubbles then. I have another method we can use to make bubbles. You can mix really fast. We can see bubbles form because we're trapping air into our bubble solution. We can then look at them. When our bubbles overlap, some of them are not spheres. Means they're not round anymore. It's because their edges are touching. So a round bubble happens because that's the strongest shape it can be in. The rest would pop because of the amount of air they're touching. When they have another bubble they can press against, they can form shapes that aren't round. Dean, you want to share?
So what I observed was that when you mix it something really fast and bubbles form, and then sometimes these kind of bubbles form where they're little hatch and the rest are all covered can just still be formed, so you can't see inside of them.
Ooh. So we have a lot of bubbles. You can't see inside of them. It's because there's many, many bubbles inside of that one bigger bubble you're seeing. It means that the light going through them is diffracted a lot. We're not seeing all the light coming through them anymore. They're not clear. Audrey, you want to share?
When I mixed it, when you said to, it actually made it so bubbly, and then when I tried to blow it out, then it didn't actually make a bubble that much.
So you told me that when we mix it, that we're having some bubbles. But then when we blow, it's harder to form a bubble. That's because you have little tiny bubbles on your bubble blower. They're not coating the entire surface that you see. You have little tiny ones that were formed. Cadence, were you raising your hand before and want to share?
I'm using the part we cut off, dipping it, and putting one in at a time so I can shape it.
Ooh. Cadence made another bubble blowing tool. I have one more test for you guys. Let's see who can make the biggest bubble on your plate. We can use the bubble solution that's on our plate or our tiny bottle of bubble solution. Either one. Dean, you're raising your hand. You want to share?
Sorry for the tiny mom. So grandma and grandpa called us before the class was over.
Oh, yeah. Sometimes our grandparents call us. Yeah, we can be happy if people are talking to us. Isn't that nice? So we can use either one of our bubble solutions. We want to make the biggest bubble. Julia, you want to share with us?
Never mind. I just made a huge bubble and now it pops.
Oh, yeah, we saw that the big ones didn't last very long. Cadence, you want to share with us?
Yeah. So if you keep blowing, it will become a cave.
I see you also have another tool you can use.
I just got the heart-shaped one because the lid was getting hard to use.
Yeah. Nice.
I just got one the size of the plate.
Nice.
Good job, Cadence.
I see Julia also has one. So Cadence and Julia both have blown really large bubbles. We're going to spend about 30 more seconds, see if anybody else can blow a really large bubble.
Oh, I blowed one that hasn't popped yet.
Ooh, great job, Cadence. Julia just blew a really large bubble. Great job. Okay, we're going to move on to another experiment now. We have pipe cleaners in our bag of supplies for today. We are going to use these to make our own bubble blower. So I see Audrey has a star bubble blower and Cadence has a heart. What other shapes can we make? We can try to make any shape we want. So I could make a circle or a triangle, any shape we want. Cadence, yeah?
I'm making a bird.
A bird, yeah.
Here it is.
Mhm.
The penguin's head and its wings.
Nice. Dean, you want to share what you're making?
So the ship that I just made is the Mars lunar lander. So it lands on the Mars. So it lands on the moon and the astronauts get out. So we're just about to make the astronaut and tape it on.
Oh, we don't need to use tape. We can bend them. Audrey, you want to share what you're making?
I actually made one of the bubbles, but it was still round and it actually was very big.
Ooh, so Audrey told me that whatever shape she just made, it still made a round bubble. Cadence, you want to share?
I flattened mine and I got bubbles and then big one.
Yeah. So when we have our shape of our bubble blower made, we can test it out. What shape do we make? Do we make our bird or our spaceship Mars lander or whatever shape our bubble blower is? Or do we make circle bubbles? Cadence is nodding. Did you want to share?
So my pipe cleaner bubble blower, I can only make circle ones.
Yeah. We're seeing that when we blow our bubbles into the air, they're still circles. The only time we saw bubbles that weren't circles was when other bubbles were touching them. Audrey, you want to share?
Yeah, actually, when I blowed one of them, it actually went up and it looked like a firework.
Ooh. Was that when it popped? When it was in the air? Yeah. So we're seeing that our soap spreads out like fireworks when our bubbles pop. Great observation, Audrey. Dean, what did you want to share?
Just some mark milliliter and then turn it into a watch shape. So then when soon dries, you can put it around your arm.
Oh, yes, you're making a way to carry your bubble blower. Cool. Thank you, Dean. Cadence?
If I blow gently and then stop blowing, it can become a firework.
Nice. Yeah, so you're seeing how you can pop your bubbles as well. When our bubble blower is bigger, does it make bigger bubbles than if we were to make a really small bubble blower? Yeah. Can we try that? So I'm going to make a really, really small circle for my bubble blower. I'm going to take another one of my pipe cleaners. I'm going to make a really big circle. I want to see which one makes a larger bubble. Dean.
So my mom just tied up the bubble blower shaped like a watch. Yeah, and it looks pretty cool because it looks like it has an antenna so it can sense stuff.
Oh, you made something else. That's cool, Dean. Yeah. Cadence. You observe.
If you blow a bubble carefully, you can make one like a tornado.
Ooh. Our bubble moves in the direction of our breath. Excellent. Thank you for sharing that with us, Cadence. Audrey, you want to share something?
So I actually mixed it a little more and put a little water in it, and it actually made a bigger bubble.
Ooh, you're changing the solution. Great job. We're going to play with our bubble blowers for 1 more minute. Dean, did you want to share something with us?
So I just adjusted it and then turned it into a chain shaped bubble blower. So that as so when you put it in, you'll have to turn them to make them flat.
Ooh, yeah, we need them flat, our bubbles. That is a Amazing observation, Dean. Thank you. You may be able to blow 3 bubbles at once with your bubble blower.
Oh, yeah. Also, I had something. So the hole is big enough to put my hand in there, so I can also carry my bubble blower with me.
Ooh, great job, Dean. You made a new invention. That way you can carry it. Audrey, you want to share?
So when I actually did it, after I blowed in, it actually made a bubble floating away, and then I caught it. And it actually had 2 together, and it turned into one because they were both stuck together.
Ooh, nice. So our bubbles can stick together, Audrey just told us. Great job, everybody. In your set of worksheets for today, there's a really cool experiment you can do at home. So Dean was telling me about how he wanted to see a bubble that was as big as him. This will allow you to do it. That way you can make a very, very large bubble.
I just made a large bubble.
Yeah, that is a large bubble. It looks like it's about 6 inches across, doesn't it? Yeah. Audrey, you want to share?
It actually, when I blowed 2 times, it actually made a bubble big the first time, and then it made a smaller one than the second time.
Ooh. So we can change how much we blow out to change the size of the bubbles. Great job. In our packet of worksheets, we also can write some notes about what we notice about bubbles. So we can talk about what we see, what we feel, as well as how bubbles are. I also want to remind everybody that you can take pictures of what you make and post them online. This will allow all the other people who are also making bubbles this week so they can see the bubbles you made. You can use the hashtag Science Matters online to post them with your parents' help. You can do that for all the things we make in this class. And one last thing before we think about what we learned, that you can change your bubble solution later. So you can change it by adding more water or soap or vegetable glycerin. That way you make your bubble solution the way you want it. You have little bubble bottles that you can pour it back into, or you can save it. We're going to go around, talk about our favorite thing that we did today, or our favorite thing we learned today. Audrey, do you want to start us off? What was your favorite bubble related thing from today?
My favorite thing about today was when we poured the 2
Soap and glycerin.
soap and the glycerin in. That was my favorite part.
You like making the solutions? Yeah. Mixing things together is fun, isn't it? Cadence, you want to be next and share?
I found if I pour some of the one type of mix on top of the bubbles, the big bubbles, it will mix them.
Yeah, so we can mix another solution, like this bubble solution, into our other solution. It's a great observation. Thank you, Cadence. Dean, what was your favorite bubble-related thing from today?
So it's that how we made the bubble blowers.
Ooh, yeah, you liked being creative and an inventor, making something.
Yeah, like this also has a net, so for bubbles floating away, yeah, I can use it to catch it. Yeah, and then it would be the shape shape of the net I used to make it.
Mhm. I would like to challenge you, Dean, to try that outside sometime. See if you can catch the bubble in that same net. Julia, what was your favorite bubble related thing from today?
Blowing and making the bubbles.
You liked making the bubbles. You liked the experiment itself, seeing whether your solution worked how you want it to work. Yeah, it's nice when our experiments come out with our expected results and we're able to make what we thought we would make. Thank you all for doing science with me today. I'm going to leave us with this picture of bubbles that we can look at and think about. We saw different colors of bubbles, such as the one on the right side here that are rainbows, or on the left, it's mostly clear. This was because of the light moving through our soap, just like rainbows form because of light moving through the water in the air. I would also like to tell everybody that one of our activities that we're going to do has to do with pond water. I would really like if everybody could take care of a sample of pond water. How we're going to do that? You're going to look through your bag of supplies. You're going to see a little tiny bottle. What you're going to do is you're going to add some clean water to that and leave it in a capped bottle in your window or somewhere nice and warm. You are going to raise up pond water for one of our experiments, okay? Thank you, guys.
A quick question about that pond water. Is it in this one?
No.
Or in this one?
So in your bag of supplies for week 5?
Oh, it's in one of the other bags.
Yeah, we're just going to raise it up. That way we have something to work with.
Okay, thank you.
And the week after. Yeah, it'll take a little bit of time for us to grow all the microbes that live in it. It will really, really help you and your parents if you keep a top on your bottle.
Can you repeat the thing again?
Yeah. So inside of your bag of supplies for week 5, there's a bottle that says pond water. It's a really small amount of water. What we're going to do is we are going to take a glass of water from our sink. We are going to pour that into a bottle, like a water bottle or a clean juice bottle. Just has to be 1 cup. And we're going to pour that bottle of pond water into that bottle. We're going to put a cap on it and put it in the sun. We are going to be growing microbes, and we can look at them later. We want it to be somewhere warm, like our window. That way they grow more of them. Every day we can take the cap off and look inside if we want. You might be able to see something growing. You will be able to see something growing when you use a microscope later on. Next week, if you're still confused, we can discuss this again, because we're going to be using it for our lesson 5. That's our last time together.
So is there like a seed or anything in there?
A C?
Like, in the little jar or something bottle? But isn't there supposed to be something that you can grow with?
The water is something called microbes. Those are very, very tiny organisms. We're going to use a tool to look at them because our eyes are going to have a hard time seeing them. Yeah. So our goal is just to put some water in with it and leave it in the sun. That way we can see them later, okay?
Okay.
Thank you. Any other questions before we leave for today? Yes, Dean?
Quick question. So the thing is, if we buy more dish soap and put them in a very large bowl and put a pencil in them, will it float?
Yeah, pencils are made of wood and they float in water. Adding the dish soap will not change the density of our pencil, so it should still float.
Oh,
Yeah,
now I get it.
so that was a great hypothesis about saying that it would float. You can try that with your parents' help if you want. Great job being a scientist. And thank you all for being scientists with me today. I will see you all next week, okay? Bye-bye.
Bye and thank you.
Thank you.
Thank you.
Thank you.
Bye and thank you.
Bye-bye.